Hi guys, welcome back to my channel. Today let's talk about another trending topic in AI, MCP, Model Context Protocol. Lately MCP has become a buzzword in the AI world. What exactly is MCP? It is a way to let your AI safely connect to real systems like DBs, files or tools and actually do the work, not just talk. I know this sounds a bit confusing. Let me give a practical example. Normally, AI, what we call LLMs, can only answer based on the text. That's why we call it as generative AI, which just generates the answer based on the questions you ask. But it cannot perform any action on its own. For example, it cannot open websites, connect to DBs, or perform any kind of actions inside a website, etc. So here where the MCP comes into picture. MCP is what actually allows the AI to safely connect to the real systems, DBs, file systems, or test tools, etc. Think of it like a bridge between AI and your system. Let me give you an example. Suppose you tell the AI, book me a cheapest flight from Bangalore to Delhi. The AI can suggest airlines prices, but it cannot actually book anything. You as a user still have to open the website, search flights, enter your details and make the payment. Here AI just guided you but did not do anything. Say for example, you integrate some MCP service to your AI or LLM. So MCPs, you say the same sentence but the booking is actually completed with the confirmations returned to you. This is what this image represents. If you see, LLM is just like a brain. With MCP, it can properly interact with the real world systems. It can talk to file systems, databases, other tools, and actually do the work. In a simple way, if I have to explain, LLM is just a brain. LLM with MCP is actually a person with brain and limbs. He can do a lot of actions, right, compared to just a brain. In my previous example of flight booking, you may think, what it is so difficult? Just write a custom integration code or access the API of that flight booking website. Problem solved, right? Why do we need MCP server? So think of it like a real-time scenario. If the LLM had to talk to just one website, then we can write the custom integration code and we're done. But the problem arises when LLM has to talk to multiple systems. Like in this example I've shown, right? The LLM is talking to multiple systems. If you see, we have a DB, we have a file system, we have some tools, we have some websites, etc. So each of these will have different APIs, different auth methods, different request formats. So for each tool, if your AI vendor, if the LLM vendor had to write custom glue code, that cannot be scaled. Let me give you a practical example. Suppose you want your LLM to help you in booking flight across, say, Indigo, AirAsia, Vistara, etc. So in this case, without MCP server, you have to write each integration code and one code per payment, one code for maybe say aggregator. So you have to write dozens of custom connections. So it's a very painful implementation. Assume we have Indigo MCP, AirAsia MCP, Vistara MCP. MCP basically what it does is, through MCP, these flight providers can just expose some of their methods. Internally, these methods call the respective APIs. Say in the Indigo MCP, they expose fetch Indigo tickets or book Indigo flights or cancel Indigo flights. In the same way, AirAsia MCP also looks the same: fetch AirAsia tickets, fetch or book AirAsia flights or cancel AirAsia flights. So all of the MCP implementations look very similar, though the APIs inside them would have been built different, but the protocol in which the MCP works is the same for all of them. So the LLM in this case finds it very easy. It just has to go through this MCP and call these methods. Internally, the respective APIs will get called. But in our previous example, for each of the APIs, we had to write a custom integration code to call the APIs. That was very painful. So through MCP, we are solving the biggest challenge when the LLM has to talk to multiple systems across multiple domains, websites, tools, etc. Here I have just tried to summarize what I explained previously. Without MCP, what happens? We need to write a custom code for each of these websites or tools to integrate with our LLM. As the custom code is very hard to scale, it is very difficult to have this approach. And also, if there is some kind of API changes, the entire flow will change. Break, sorry. With MCP, what happens is all of these websites or tools follow a common language that's called MCP protocol. As they all look very similar, it becomes very easy for the LLM to get integrated, and it is very easy to expand also. Let me summarize quickly and paint a picture so that you can understand precisely. So a tool, when I say MCP server for a tool, it means this tool is exposing certain methods for certain actions. Suppose for an action 1, there is a method 1 defined, and for action 2, there is a method 2 defined. Method 1 takes two parameters. Inside this method, this API will be called, which basically performs this action. In method 2, this API will be called, basically it does this action. Now in the chat, you as a user ask LLM to perform say action 1. What now LLM does is it goes to this tool and calls this method. So this is where the LLM's intelligence comes into play. It now precisely chooses based on the MCP definition, right? If you have asked for action 1, it will go and call this particular method, and from your prompt it picks up these two parameters and passes here. Same way, if you had asked for action 2, LLM smartly will go and call this method, and in your prompt it will pick up this P3 as an input and calls this method. Now say in our example, LLM calls method 1 and passes these two parameters here, and the API gets called and the response is sent back to the LLM. That will be shown in the chat. So whatever query you had asked, LLM performed the action and is now showing the results. In this case, you may have a question: how about if we had directly exposed the API to the LLM? So in practical scenario, just imagine the same prompt throughout worldwide, multiple people might be asking. So in that case, what happens? LLM will tend to call the same API endpoint multiple times. Says, for example, if the endpoint is paid, then there is a huge cost incurred. And also, if we give direct access to LLM, it becomes a security breach as well. So to avoid all this, what we do is we wrap the API inside the method and show it as MCP. So in this case, even the APIs are safer, and based on the prompt, LLM uses its intelligence to specifically go and call which method and pass the parameter. Hope you understood the concept precisely. The entire MCP architecture has three components in it: the host, client, and the MCP server. What is the host? Host is nothing but the AI tool in which the LLM lives. For example, Cloud Desktop or any AI IDE like Cursor, where you have the LLM with whom you can talk. That is called the MCP host. MCP host is nothing but an AI app that thinks and makes decisions. Next is MCP client. So this is the protocol that actually connects the host to the server. It tells the host how to connect to the server, and also it sends the tool request and also gets back the response from the server to the host. For example, a file system client or a GitHub client or a database client, all of these tells how to connect to that specific MCP server. Next, the important part is MCP server. So this is actually the tool provider. It is the one which does the work. It exposes the tools like read file, get data, etc. So this is what basically gets the data from the external APIs and gives the data back to the client, to the host ultimately. So let me give you a practical example on this architecture. Imagine you are using IntelliJ with GitHub Copilot and you want to read an external database system. So in this case, your IntelliJ IDE where the Copilot is enabled becomes the host. This is where you prompt your questions, right? So that becomes the host where the AI basically lives. And the client is the database client which tells the host how to connect to that particular external database server. As I told, the client will facilitate all the communication between the host and the server. And then the last part is the server, which is the database MCP server, which basically exposes the capabilities like running the query, reading the table, or getting the schema, etc. So this is where the actual execution happens, and this will be returned back to the host. So finally, we as a QAs should understand why it is actually important for us. Think of MCP as a bridge between AI and your testing tools. Before MCP, AI could only suggest steps. Still, you had to do manually a lot of steps like executing Selenium scripts, pull data from database, update Excel sheets, etc. But with MCP, AI can actually perform actions safely via MCP server. For QAs like us, this means a lot. We can automate all the repetitive tasks, we can reduce manual errors, and we can scale very faster. So, in short, MCP turns AI from an advisor into an executor, letting you focus on testing strategy instead of repetitive operations. I hope this video was very helpful for you in making you understand the MCP in and out. Thank you for watching. Please keep following this YouTube channel for more contents like this on AI and QA. Thank you.